chart, which will allow us to change what we're doing for QC. The first two tools, they'll help us assess performance. It helps us understand where we are. The third and fourth tools, they tell us where we can go, what changes we could make, what impacts we could make to our QC rules and our QC frequency. Now, Six Sigma, some of you have already heard of Six Sigma, and some of you know that my father and I talk a lot about Six Sigma. We're very strong proponents of the approach, but I do want you to realize that this is something that is taking the whole industry. It's not just us talking about it. We even have IFCC committees saying this is how you should judge the quality of tests. The Committee on HbA1c standardization saying if you're going to choose an HbA1c method, use Sigma metrics to make the decision. IFCC EFLM committees on the pre-analytical and post-analytical quality indicators saying when you measure those quality indicators, put them on the Six Sigma scale. That will give you not only your error rate, but give you an idea of, are you doing a good job? Are you doing a world-class job? Or are you really quite poor? It'll help you identify where you need to make the most improvements. At AACB a couple of years ago, a collective opinion paper came out of the conference which recommended Six Sigma metrics should be adopted as a standard part of your QC practices. And now we're seeing it start to emerge even in our EQA reports. So we've seen it in South Korea, we see it now in the Belgian EQA survey. You're participating in EQA, you get your report back, and it tells you your bias and your SCI and all those usual statistics, but now it's coming also with a Sigma metric. And actually saying, well, here's your bias, and by the way, this is how good your test is. And then on the commercial end, most of the control vendors have added it to some part of their informatics. Bio-Rad, one of their programs, will automatically calculate the Sigma metrics for you. MAS will generate some of the method decision charts right in their QC management. Technopath also generating QC design suggestions with their EQA program, and Randox as well. I forget, I think they may be calculating Sigma metrics as well. Again, the concept of Six Sigma comes down to the number of defects. Now, it may be easier to think about defects as false positives and false negatives. If you have 1 million reportables, how many of those results are clinically different in a significant way than what's actually happening to the patient? Will change the diagnosis or treatment of the patient. So you put it on a scale of defects per million. Per million reportables, how many false positives and false negatives are occurring? And then that converts into this scale of 0 to 6. Where Six Sigma, now you're saying, I only have less than 4 out of 1 million reportables where I'm going to get the clinician confused. 3 Sigma, again, usually the minimum level acceptable performance is 67,000 false positives and false negatives per million reportables. If you have a test where you're repeating a lot of controls, recalibrating frequently, have a lot of troubleshooting episodes, you're calling the technical support line frequently, you're calling the technical support line so often you know who's working on every shift, you're calling the technical support line so frequently they know your name, those are all the symptoms of a 3 Sigma test. If you have a couple of those, that's already a hint. That test is operating at a 3 Sigma level. Now again, just to give you a basic idea why it's called Six Sigma. In industry, we say there's a tolerance specification, a tolerance limit. So there's a value you should be getting, and then there's an acceptable deviation from that true value that won't change the outcome of the process. But once you exceed that tolerance limit, now that's when it becomes a defect. And the theory is if you can squeeze down your variation so that 6 SDs will fit between the true value and the tolerance limit, then that's when you know you will only have less than 4 defective results out of 1 million outcomes. That's where 6 comes from Six Sigma. For us in laboratories, we don't talk about tolerance specifications. Instead, what we talk about is allowable total errors. When you exceed the allowable total error, that's when you generate a test result that is significantly, clinically different than what's really happening with the patient. It's the false positive, it's the false negative. So when you exceed the allowable total error, that's when you're going to be generating those defects. But where do we get the allowable total errors? The good news is they're mostly already defined by many different agencies around the world. In the US, we have the CLIA regulations, which directly tell labs how good they need to be. It's written into law. For about 82 different tests, you have to be this good